Hi everybody, my name is Reese and this is my short video series where I explore different statistical concepts in SPSS in less than 10 minutes. In this video, we will be exploring the concept of interactions in SPSS. The purpose of this video is to serve as a precursor to factorial ANOVA. We will be exploring interactions using independent samples t-tests in this video. Quick disclaimer, this video does not explore the appropriate assumption tests for this analysis. I have assumed that all assumptions have been met. If you are performing your own analyses, please make sure you test for the relevant parametric assumptions. Before we jump into the SPSS environment, let's clarify what we mean by an interaction. So an interaction is when the relationship between an independent variable on a dependent variable is somehow different or changes according to levels of a second IV, or a second independent variable. In research, very few relationships are simple, or very few relationships are bivariate. And what I mean by that is, the world's complicated, so it's very unlikely that a complex phenomenon, particularly in psychology, is simply the product of one IV on a DV. In reality, it's more likely that multiple variables or multiple relationships are at play here. So in this video, we're going to start that journey of exploring multiple independent variables at a time. So in this video, I will be testing whether cholesterol levels differ significantly between two independent variables. The first independent variable is going to be what a group, or what type of patient I have. I'm going to have heart attack patients and I'm going to have control patients. The second independent variable I'm going to have is gender. So my hypothesis overall is going to explore whether cholesterol levels differ as a function of being a heart attack victim or not, and then secondly, whether this relationship is somehow different for males than females. Okay, I've moved into SPSS now, and as you can see from my data file, I have three variables. I have what group my participants are in. So I have whether they're a heart attack patient or a control patient, their cholesterol levels, and then finally their gender. Under the variable view, you can see the different components of these variables as well. Now I do have the link available to this data set in the description below, but please bear in mind that the original data file only had group and cholesterol. I've actually made up some mock data here for gender. So this particular variable gender is not real. I've just entered it into this data set to conceptually show you what an interaction is. I've already analyzed this data in terms of an independent samples t-test in another video, where we found that cholesterol was significantly higher in heart attack patients. I'll quickly show you that again, just for a bit of a revision. So compare means, independent samples t-test. I'll put group down there as my independent variable, letting SPSS know how those value labels were coded. Cholesterol level is my test variable. I hit OK, and you can see here that the mean cholesterol level was higher for heart attack patients, and that was significantly higher as well. Now, what an interaction does, it extends this relationship by looking at a second independent variable. Now, what I want to be able to do via an interaction is to see, does this relationship here, where cholesterol levels differ significantly between heart attack patients and control patients, does this relationship hold true in the same fashion for both males and females? Now, before I actually analyze this data, I want to show you what that looks like in a graph. So I'm going to go up here to Graphs and then Chart Builder. And I'm going to do a line plot. And I'm going to just show you what this looks like by putting cholesterol levels on the y-axis, the group on the x. I'm going to set different colors here for gender. And I'm going to go ahead and select OK. So here you can see I have a graph where the blue line represents males and the green line represents females, and I've got my two different groups down here, heart attack patients or control patients. Let's look at just the blue line by itself here for a moment. It looks like cholesterol levels are significantly higher for heart attack patients than control patients for males. In the green line, it looks very similar to that, so it looks like heart attack patients are a little bit higher in the heart attack group compared to the control patient group for females. But can you see how the blue line is steeper? This relationship here for males looks much stronger than it does for females. So in other words, the relationship here between the patient group on mean cholesterol levels appears much stronger in males than it does for females. So again, I'll say that one more time. The effect of group here on cholesterol level seems to be larger or greater for males than it is for females. And that's exactly what an interaction is. An interaction is when the effect of one independent variable on the dependent variable is somehow different or changes according to levels of a second independent variable. That's what an interaction is. Now, when you become a little bit more advanced in your analyses, you can actually test for this interaction using something called a factorial ANOVA. We won't be doing that today. We're just looking at the concept of an interaction. We can explore that effect or that analysis in a different video. What I'm now going to do is I'm going to run this t-test separately for males and females to show you the interaction statistically. So I'm going to go up to data and then use the split file function here. I'm going to split the data file by gender, compare groups, go ahead and hit OK. Now that I've got that split file function on, SPSS knows to run every single analysis separately for males and females. It's going to split the data file for me. So if I go back up to analyze, go into compare means, back into independent samples t-test, keep everything the same as what it was before, hit OK, I've actually performed two different t-tests here. The first one's for males, the second one is for females. Again, first one here for males, second one here for females. Let's look at males in isolation for a moment. It looks like the heart attack patients have much higher cholesterol levels than the control patients, and this appears to be a significant difference as well. However, the cholesterol levels for females, whilst they're a little bit higher in the heart attack patient group, they're only a little bit lower in the control patient group. And when we look at the statistics here, this difference is actually not significant. So we can actually see statistically here, using t-tests, that the effect of the type of patient on cholesterol levels is only significant for males and not significant for females. So we can demonstrate an interaction both graphically and test for it statistically as well. That wraps up our short video exploring the concept of an interaction. If you're confident in your ability to observe how the effect of an IV on a DV can differ according to levels of a second independent variable, you are now ready to start exploring factorial designs. I hope to catch you next time exploring more cool things in SPSS in under 10 minutes.